Hello everyone and welcome back to another new video. And in this video we're going to take a look at the latest exoplanetary research by the JWST. And this particular research is being headed by Brittany Miles from the University of Arizona, and they have published all of this work in this beautiful research paper. In this particular video I'll sort of give you a brief overview of how the planet is, where it is, and then how it's sort of composed and what can we learn about it. Again, James Webb does excellent exoplanet research because of its really improved sensitivity and the ability to resolve finer and finer spectrum. Astronomers for this particular study have actually got a plethora of spectrums, and which really reveals all of the interesting composition that the planet already has. Imagine yourself waking up in this planet where you sort of look up at the sky and see two really small stars, just like our sun, but really far away and small, probably a dim environment, and then all of a sudden you see a lot of sandstorms coming towards you. This is typically what you would expect if you were living in this particular planet. This particular planet is about 40 light years away from us. This planet completes a day within 22 hours, so kind of comparable to Earth but slightly shorter. But what is really different is that it has orbital period. The time it takes for the planet to revolve once around the sun is about 10,000 years, way more than the orbital period of our Earth. And the reason for that is simply this planet is really far away from two of its hosts. So it's actually 4 times the distance between Earth and Pluto. Overall, this planet is on the bigger side and it's pretty hot out there. In fact, the average temperature is about 1300 degrees Fahrenheit or almost 830 degrees Celsius. So what James Webb is so far revealing is this planet has a rich composition. As you can see, there are like several elements present in the planet. The way you understand this is using a simple technique called transit spectroscopy. I have actually made a very detailed video going over the I'll put a link to this video up there. Please go ahead and check it in order to understand what transit spectroscopy is in simple terms. So James Webb is using its various filters present in the near spec instrument, and a near spec is near infrared spectrograph and as the light from both of its stars sort of passes through the planet's atmosphere and falls into our telescope, that light is split up into its component wavelengths, and depending on the composition of the atmosphere, certain wavelengths of light will actually be absorbed by certain elements present, and that you can see in the spectrum that we finally get in the telescope. And depending on which particular wavelength has been absorbed, we can actually pinpoint as to what elements are present within the atmosphere. This is the basic concept of transit spectroscopy, which James Webb is really nicely designed to do. In this particular atmosphere, what James Webb reveals is a lot of H2O, methane, carbon monoxide, and finally a lot of silicates in the form of sand. Basically what's happening is the atmosphere is constantly rising and mixing, which is bringing up the hot matter and pushing the cold material down, and as a result of this, the brightness of this planet actually changes very dramatically. The spectrum not only tells you the constituents that are present in the atmosphere, but it also tells you about the size of the dust grains that are actually present in the atmosphere. So the atmosphere of this particular planet has a mixture of both large and small silicate dust grains, basically silicate sand grains, and the finer silicate grains in its atmosphere may be more like tiny dust particles in smoke. Now what astronomers are trying to say is sometimes planets get stuck in a brown dwarf stage. That is, it's basically a failed star. It was not huge enough to sort of start a nuclear fusion reaction at its core and heat up the entire body and form a star. Whereas these fell sort of short in size, and that process couldn't happen. This planet has a surface gravity which is actually less as compared to brown dwarfs. Now, brown dwarfs, as I said, are failed stars, and we have actually characterized brown dwarfs pretty well. And so this has a relatively less surface gravity as compared to a brown dwarf. Biggest consequence of this is that the silicate clouds can appear and remain higher in its atmosphere, where Webb can actually detect them really nicely. Another reason for its sky being so turbulent is the planet's age. Basically, in astronomical terms, it's quite young, only 150 million years old since it actually formed. Right now, this planet is actually a pretty hot and young stage, and over the course of time, this planet will sort of cool down by radiating all of that heat. As a result, what might happen is the turbulence will actually sort of slow down and the skies might get more clear. That is, the atmosphere will sort of settle down on the planet even more. And we already are getting signatures of H2O, carbon monoxide, methane. So it has a lot of those essential elements that are crucial for supporting life. Having a lot of planets like this can actually lead us towards how life sort of first developed in our own planet Earth. So remember, Earth also has gone through all of these phases before. Initially, when it formed, it was really hot and it definitely couldn't support life. But as time went on, the Earth sort of cooled down, life started to emerge out of it. Having a lot of planets like this can actually help us to understand how life forms in a particular planet. Again, I'm not saying that this particular planet has some kind of biosignatures and life forms, but it is at such a good stage that if we study this planet and similar planets like this, we can have a pretty good idea. Without really going into much complexity, I would just like to end this video here. I wanted this video to be short and compact and just give you the basic details of this planet. So if you like this video, again, please go ahead and subscribe this channel, and don't forget to share it with people who are as interested and curious as you guys are. And with that being said, I'll catch you guys in the next video. Till then, take care.